For centuries, humans have wondered what life might be like in other universes. Thanks to the James Webb Space Telescope, JWST, the most advanced space observatory ever built, that age-old question may finally be within reach of real scientific exploration. While examining Proxima Centauri, the closest star system to Earth just 4 light-years away, scientists have observed strange anomalies from one of its planets, Proxima b. These oddities, believed to be artificial lights, have sparked intense curiosity within the scientific community. But what exactly are these lights? And could they be evidence of intelligent life? Join us as we delve into the James Webb Space Telescope's potentially groundbreaking discovery of what may be city lights on a distant world, an observation that could change our understanding of life in the universe forever. So far, Earth is the only planet we know to harbor life. Since the dawn of civilization, people have looked to the skies, wondering if we're alone. In 1984, American researchers Jill Tarter and Thomas Pearson launched a search for extraterrestrial intelligence, SETI, project to seek answers. SETI's mission was to detect extraterrestrial radio signals, waves capable of traveling across vast distances, using the powerful Allen Telescope Array in California's Sierra Nevada mountains. Despite decades of effort, no confirmed alien signals have yet been discovered. Enter the James Webb Space Telescope. Positioned about 1 million miles from Earth, this massive observatory is equipped with ultra-sensitive instruments that make it capable of detecting even the faintest signals from exoplanets orbiting distant stars. Its launch has supercharged our efforts to explore the unknown. Not long ago, no planets beyond our solar system had been confirmed. Today, NASA reports that over 4,000 exoplanets have been identified, and millions more may exist across the cosmos. One possible early sign of life on these distant worlds is extraterrestrial vegetation. When the Galileo spacecraft journeyed to Jupiter, it turned its instruments back toward Earth and detected a strong, red-edge signal, a biosignature caused by vegetation, reflecting a blend of red and infrared light. A jungle-covered planet, for example, would emit a very strong red-edge signal. JWST aims to detect similar biosignatures on exoplanets in the habitable zones of their stars. By observing how starlight passes through a planet's atmosphere, it can use spectroscopy to identify the chemical composition of that atmosphere. Specific gases absorb specific light frequencies, creating a kind of fingerprint, an indicator of what's happening beneath the clouds. With this method, JWST may detect atmospheres similar to Earth's, containing oxygen, nitrogen, and carbon dioxide, key ingredients for life as we know it. It could also spot signs of intelligent life by identifying compounds that don't occur naturally. One such compound is chlorofluorocarbon CFCs, used in refrigeration and industrial cleaning. If a telescope on another planet were aimed at Earth, it could easily detect CFCs in our atmosphere, strong evidence of industrial activity. If JWST were to find such pollutants in the air of a distant planet, it would be a powerful indicator of technological civilization. However, not all life has to look like ours. Some organisms, like extremophiles, thrive in environments considered deadly to most forms of life. These microorganisms survive extreme conditions, temperatures above 250 degrees Fahrenheit, or in highly acidic environments with a pH below 3. While alien life may not resemble anything on Earth, scientists believe it's most practical to first study Earth-like planets, those with stable temperatures, liquid water, and orbits around stable stars. Our own sun is a G-type yellow star, moderate in size and temperature, and planets orbiting similar stars are among the best candidates for life. By studying these worlds with JWST, we may soon uncover clues that answer one of humanity's oldest questions. Are we truly alone? Red dwarf stars typically have lower luminosities, cooler temperatures, and much longer lifespans than our sun, conditions that increase the likelihood of finding planets suitable for study and potentially for life. Because these stars are more common in our universe, the chances of discovering life-supporting planets around them are higher. A notable example is the TRAPPIST-1 system, located about 40 light-years from Earth, which orbits a calm red dwarf and contains 7 rocky, Earth-sized planets. 3 of these lie in a habitable zone, where liquid water could exist, making the system a prime target for the James Webb Space Telescope's, JWST, early missions. Despite being smaller and cooler than our sun, the TRAPPIST, one star emits steady, Earth-like light due to the proximity of its planets. Another key candidate for extraterrestrial life is Proxima Centauri, a red dwarf located just 4.25 light-years away. In August 2016, astronomers discovered Proxima b, an Earth-sized planet with about 1.3 Earth masses, located in the star's habitable zone, where the conditions might allow for liquid water. However, Proxima b's close orbit, just 4.6 million miles from its star, exposes it to strong stellar winds that could strip away its atmosphere. While it only receives 65% of the sunlight Earth does, that could still be enough to support liquid water, provided it has a heat-trapping atmosphere. Like our moon with Earth, Proxima b is likely tidally locked, showing the same face to its star at all times, creating one hemisphere in perpetual daylight and the other in constant darkness, resulting in extreme temperature differences. Proxima Centauri emits only 5% of the sun's light and is just 18% as massive. Though Proxima b might appear barren, the possibility of liquid water, and thus life, remains if an atmosphere exists. However, the planet receives nearly 3 times the amount of high-energy radiation, including X-rays and ultraviolet light, compared to Earth. Without a protective magnetic field, this radiation could make the planet uninhabitable. Additionally, on tidally locked planets, volatile gases on the night side can freeze out, potentially breaking down the atmosphere over time. On Earth, volcanic activity and a strong magnetic field help sustain our atmosphere. But since we don't yet know whether Proxima b has volcanic activity or a magnetic field, it's hard to confirm if it has a stable atmosphere. Still, if Proxima b does have an atmosphere and surface seas, this could point to a potential biosphere. Speculatively, advanced civilizations, if they exist, might use solar power stations on the day side to light and warm the night side for habitation. Efforts are underway to determine whether Proxima b transits its star, as this will allow astronomers to measure its size and mass, assess its density, and confirm its rocky nature. During such transits, starlight passing through the planet's atmosphere could reveal its composition. Unfortunately, the chances of observing a transit are only about 1.5%, and Proxima Centauri's frequent solar flares make detection even more difficult. As astronomer David Kipping of Columbia University notes, the star's instability presents a major challenge, as flares can cause rocky planets to absorb and re-emit radiation erratically. Infrared observations and the possibility of city lights on Proxima b. Rocky planets emit a distinct form of infrared radiation, especially when orbiting cooler stars like Proxima Centauri. Fortunately, the James Webb Space Telescope JWST was specifically engineered to detect such infrared signals, giving it a significant advantage over its predecessor, the Hubble Space Telescope. Proxima b's infrared signature is crucial for identifying characteristics of its atmosphere and possibly much more. Thanks to its superior infrared sensitivity, JWST could potentially detect artificial lighting on the night side of Proxima b, even if it's as faint as city lights on Earth. If these lights fall within a narrow frequency band different from the star's natural emission, JWST might distinguish them from natural light sources. It's also speculated that Proxima b's day side could be covered in solar panels reflecting starlight, which would further indicate the presence of intelligent design. Proxima b experiences a stable cycle of day and night due to its orbital pattern around its red dwarf star, leading to extreme temperature fluctuations. If the planet lacks an atmosphere and is composed entirely of exposed rock, its day side would emit absorbed energy as blackbody radiation, while its night side would become a frigid, frozen landscape. However, if the temperature difference between the two hemispheres is modest, it could imply the presence of an atmosphere moderating the heat exchange. JWST requires just 11.2 Earth days to collect enough data to detect artificial city lights on Proxima b's night side. Such a finding could provide the first tangible evidence of intelligent extraterrestrial life. The planet might harness solar energy during the day, powering cities that illuminate the night, suggesting a technologically advanced civilization. Still, scientists remain cautious. While the detection of artificial lights would be revolutionary, it's essential to consider alternative explanations. Natural phenomena such as volcanic activity, lightning, or unusual atmospheric conditions could also produce similar infrared patterns. Since JWST's technology is still relatively new, astronomers are carefully refining their analytical techniques. The telescope's mission includes continuous monitoring of Proxima b and other potentially habitable exoplanets, aiming to expand our understanding of their atmospheres and surface conditions. Even if artificial lights are detected, it would take years of follow-up observations to confirm their origin and rule out natural causes. If proven to be signs of intelligent life, this would mark one of the most significant scientific breakthroughs in history. It would challenge our assumptions about the uniqueness of Earth and redefine humanity's role in the universe. Such a discovery could inspire global cooperation, unified by curiosity and a profound realization that we are not alone. Moreover, it would reinvigorate efforts in space exploration and technology, pushing us to develop new tools and methods for reaching distant worlds. The ongoing search for city lights on Proxima b is not just a scientific endeavor. It's a symbolic quest to answer one of humanity's oldest and most compelling questions. Are we alone? As JWST continues to relay data from the farthest reaches of space, the hope of discovering intelligent life grows stronger. The confirmation of such life on Proxima b could revolutionize our future, opening doors to interstellar communication and a deeper understanding of life's potential across the cosmos. What once seemed like science fiction is now inching closer to reality, and the next generation of scientists may be the ones to finally uncover the truth.